Hi, this is my presentation of Osborne Reynolds and his life and his contributions to the physical world. Um, so yeah, we'll start right now. Alright, so Reynolds was a prominent physicist and innovator, and his major area of work was in fluid dynamics, but he also had influences in other areas of physics as well. He's most known for his Reynolds number, and we'll be talking about that later in the presentation. And he helped explain phenomena like, for example, when you walk on wet sand, why the water seems to dry around wherever you step. And we'll be getting into that later. So, now we'll be talking about Reynolds himself. He was born in Belfast, Ireland, and during his schooling, he had a high interest in mechanics. And after his primary schooling, before going to college, he took up an apprenticeship with Edward Hayes. And he went to Cambridge, actually, and he studied mathematics and graduated in 1867. He was one of the first professor of engineering in England, and at the time it was a new professorship. And he held the post until he retired in 1905, and he finally died on the 21st of February, 1912. Now, he published over 70 scientific and research reports, and his most famous experiment is the dye experiment, which is on the left, and we'll be looking at that later as well. Like I said, he was most famous in fluid dynamics, but he had influences in other areas of science as well. Now, his contributions, like I said, he actually didn't introduce the Reynolds number. He was most known for using it to help classify the flow of liquids and to classify the flow under varying conditions of flow. And basically, I'll be getting into fluid dynamics a bit now. It's just a bit of background info. Alright, so basically, what we need to know right now is that the flow of liquids is characterized into two subgroups, laminar flow and turbulent flow. And like I said, I'll just be telling you guys the definition. I won't be getting into too much detail about this. But what you need to know is that laminar flow, it occurs in layers like this. And there's no mixing of these layers, and the velocity is constant throughout, as you can see. So what's important here is that the velocity does not change at any point that we choose throughout the entire flow. And let's move on to turbulent flow. So now, this might not seem more than just like a couple of scribbles, but it actually characterizes turbulent flow, because it's like flow, but under the influence of several agitations. So the velocity is not constant in any fixed point that we choose. Even in the same point, as time passes by, the velocity will be continuously changing. So just to sum it up, laminar flow is flow in layers, and the velocity is constant. And turbulent flow is really crazy flowing, but the velocity is constantly changing, and it goes in different directions. That's what we need to know for now. And this is just a video of the dye experiment. And as you can see, what they did, they put a dye on water, and they're passing it through a tube. And they'll be slowly increasing the velocity of the water flow. And you can see it gets a bit, you see the dye being separated. It gets mixed with the rest of the water. Yeah. Alright. So now back to turbulent flow. We saw that as the water became more turbulent, the dye got mixed more because of this constant, you see the arrows moving around and around, so the water is mixing with itself, and the dye got mixed as well. So that's how we can explain that experiment. And now Reynolds number is defined as the ratio of inertia force to the viscous force, and you have the formula there, but I want to point your attention to the velocity of flow. That's what we're looking at right now. I know the other stuff might not seem as, like we haven't learned that stuff yet, but we'll look at it soon. Now, velocity is directly proportional to RV, which is Reynolds number. And from our experiment, we can say that as RV gets larger, the flow becomes more and more turbulent because we increase the velocity slowly. And we saw that it did become more turbulent. Alright, now we'll just be looking at some examples of laminar and turbulent flow. So when you have tap water, when you release the current slowly, because the velocity of the flow is low, we have more of a laminar flow, and when we let it out full, like completely, we see turbulent flow. I'm sure you've noticed this before.